Hi everyone, lesson 2.3 is a little bit different. Rather than us tackling problems, having me write out the solutions as a recording, this lesson is the first of multiple lessons. There'll be typically one lesson per unit moving forward, looking at using Microsoft Excel to solve the exact same problems that we've been looking at so far. Okay, all of you during one of your terms would have taken the Microsoft Excel course, BCO 118. So a lot of you will understand a lot of what I'm doing here. The very last module in that course actually talks about some of these formulas just without giving you the background as to what they mean and what kind of variables go into it. So I'm going to walk you through each of those, as well as just giving you a brief refresher on how to format things, make things look presentable. Okay. So I have multiple problems here that we're going to solve, each looking at a different item to solve. So we have present value and future value. We're going to talk about finding payments, finding the periodic interest rate I, and also finding the total number of compounding periods. So we're going to start with finding present value. Now, remember from, anytime you're looking at an Excel spreadsheet, I have two columns here. I have term and value. So value is the actual number that we're going to take from our question and input it in. But you always need to show what the term is. Okay, what is that value you're describing? And again, you know what that value is. Okay, it's you that's putting that number in based on a certain question or based on certain criteria if you're in the workplace that somebody's giving you. But you have to stop and think that you're probably not the only one that would use this spreadsheet. So you have to make sure that you properly label each of your inputs and each of your outputs so that the next person that opens your spreadsheet will understand what they're looking at. Okay, so we're going to walk through this question, and as I do each variable here, I'll put in the term and its corresponding value. Some of these will not come from here. They'll come using formulas that we've seen in class. Okay, so we'll start by reading the question. Find the present value of an annuity with payments of $3,000 made at the end of 5 consecutive years if interest is 6% per annum compounded annually. So remember back to when we do a question, I have a sidebar. Okay, and we have to think about what each of these items are that we need to use. Okay, we have payment, which I'll write first, and I write payment and then comma, and I actually write what the variable would be if you were actually looking at the physical formula, so PMT. Now you have two options here. You can either press enter to go down in the same column and keep inputting your variables, or you could be in this formula and you can press tab. That would bring you to the column beside it, in other words, column C, where you can input a value. Okay, so in this case, our payment was given in the question as $3,000, so we can input that value. Now, we don't have another column to go to here, so if you did this and you pressed enter, it brings you back to your initial column B, where you could then input the name of the next term, and if you press tab, when you're done, it would go back over here and you can input its value. Okay, so that's the way that I'm going to do it. Before we go to our next value, I just want to describe a couple things here. So in my spreadsheet, it came up as $3,000. Okay, again, with the money, with dollar sign and having dollars and cents. And that was because I had it set up that way. If you didn't, remember, if you go back up here to where it says number and you click the drop down menu, it's going to come up as general here where it says no specific format. Okay, but going back to what I said, you need the next person to open your spreadsheet to understand what each of these are. This payment is in dollars. Okay, it's not in percent. Okay, it's not in a different currency. It's in dollars. Okay, So I'm going to click this drop-down menu, and you can either click currency or you can click accounting. Okay, a lot of times with currency, it could be if you're changing it to other currencies as well, like pounds or like euros. Okay, so I'll select accounting for the purposes of this. And it changes it again to show the dollar sign as well as dollars and cents. Okay, so now I press enter. You notice it went down here, and that's because I did not tab from this first. So if I did do tab and then enter, it will go back to here. Okay, so just one thing for you to get used to. So the next term we always looked at was what else was given in the question. Okay, well, the nominal interest rate. So I can type nominal interest rate. Now I'll type a comma, and remember that term is J. Okay, so I'll type in J. So now I'll press tab to go to the cell to the right. And here we have several different options for how we want to input this. Okay. Our first option, okay, remember this is just sitting here, up here as general. So it's not under any specific format. So we could just convert that ourselves, 6%, knowing that it's 0.06. Or, okay, we could do it just like we do in a problem. Remember, if you're doing a formula in Excel, you start with the equal sign. And you can do, remember, take 6 divided by 100, removing the percentage sign. And if you press enter, it will come up as 0.06. Notice my cursor or my active cell went back to column B. Now, alternatively here, okay, you can actually, instead, I'll delete that, you can change this cell to be a percentage. Okay, so I can select percentage, and now I can just type in 6, and it will come up as 6%. Okay, meaning that it will actually use the decimal number for that because it understands that the number you put in here is a percent. Okay, any of those three methods will work. Okay, so I'm going to leave this here as a percentage. Okay, our next item we can put in, remember, after we found nominal interest rate, we normally looked at our number of compounding periods per year, which, if you remember, I put a comma, was M. Okay, again, I press tab. And it's given in this question that it's compounded annually. Okay, meaning that our number of compounding periods per year is 1. Notice I moved cells, so it did not go back to cell B here. But if I had started here, press tab, and then enter, it would go back to that format. So just like we're solving a problem, we have J and we have M. So now we can find the periodic interest rate. Okay, again, we put a comma, that is I, and I'll press tab to go to the right here. Now, if we're solving that, remember, that's equal to our nominal rate of interest divided by, which is / our number of compounding periods per year. So I'll press enter there. And you see it comes up as 0.06, even though if you were to look at these, this looks like it's going to be 6 divided by 1. But remember, because this cell is formatted as a percentage, it knows that that is 6% or 0.06. Okay, so we can do the same thing here. We have this as a general item. We can again change that to a percentage, and it comes up as 6%. Okay, understanding that that number is actually 6%. We can go to our next item that we usually look at. Okay, we usually think about our length of investment. How many years is it? Okay, and that's important. So make sure that in brackets here, remember, length of investment never had a term. Okay, when we found our total number of compounding periods, it was always our length of investment in years multiplied by M. Okay, our number of compounding periods per year. So remember, anytime we're looking at one of these, I have formulas here. Okay, and I've got variables for each one. You need to specify what those units are. Okay, because somebody could come into this formula and think, oh, I have an investment for 26 months. Okay, so they might try and write 26 here, but your length of investment in these questions is typically in years. Okay, so they would have to convert that 26 months to years. Okay, so it's very important to make sure you specify units. Again, you're always thinking about the person coming after you looking at this spreadsheet. So I'll press tab. Our length of investment given in this question is 5 years. So I will type in 5. Now we can find our total number of compounding periods, which remember, that was n. Okay, so comma n. I press tab. Our total number of compounding periods, again, is a formula. It's equal to our length of investment multiplied by our number of compounding periods per year. So if I press enter, okay, again, it goes back down here to B. Now we are at the last piece of the puzzle. Okay, we have all of our variables. We just need to calculate our present value. So this is going to be our present value. Okay, remember in comma PV. Again, always stating what each value is. And for this one, I'm actually going to take this a step further. See, this was bolded automatically, but I want you to show you that it's an output. So I'm going to highlight these cells, and I'm actually going to change the text to green. Okay, green for money. Actually, I'll just do this one, and I'll show you why in a second. So now we're under our present value, and we need to use a formula. So the formula for present value is pretty straightforward. It's equal PV. Okay, just like the term here, you're going to see that a lot of the terms we use, like PMT and PV and FV for future value, are the same as the names of the formulas in Excel. So equals PV, you'll see it comes up here with PV right there, and it says the returns the present value of an investment, the total amount that a series of future payments is worth now. That's just describing what the present value is. So we start with our left bracket, and remember in your Excel class, what it does is it tells you what each of these are, okay? So in this case, it's showing 5 possible inputs, and the one that's bolded is the one that we're looking at now. The first one is rate. Okay, rate is your interest rate. Now remember, when we're talking these questions, it's your periodic interest rate, not your nominal rate. So I'm going to select my periodic interest rate, put a comma. You'll see that our second item here is now bolded, NPER. That's our number of periods. That's our total number of compounding periods. Again, think back to the actual manual version of this formula. It's the same variables you'd look at to solve that formula. So our number of periods is N. Select that. The next item is payment. Okay, our payment is provided here, so we select that. Then we have 2 more items here. Future value, FV, which is in square brackets, and type, which is also in square brackets. Those are optional inputs. Okay, those are ones that you may not know. Oftentimes you won't know the future value. Okay, so if you don't know them, you could just remove that comma, end bracket, and the formula will come out. Okay, and that's because those were optional inputs. You'll see this is a negative number, but negative $12,637.09. I'll explain why that's a negative in a second. But going back to our formula here, you can actually, if you know one of them, and you may actually end up knowing type, I'll explain why. If you don't know it, you can just type in 0, and that assumes that you don't know what it is. The last one is type, and there's 2 types it shows, the end of the period or the beginning of the period. So we're talking about ordinary simple annuities in this unit, which means that payments are at the end of each period. Later in our course, we are going to talk about annuity due. Okay, those are when payments are at the beginning of the period. So that changes what your present value calculation would be. The normal assumption is payments are at the end. Okay, that's why that piece is normally optional, but there are situations where you might have an annuity due. Again, if you don't know what it is, type in 0, assume it's the end of the period, okay, because that's the basic assumption, and you'll see the same number appear, even with adding those 2 zeros to that formula. And you'll notice that it's negative, okay, and it's in red. This is why I didn't color code that to green or override the cell, because I wanted to show you that. It's showing a negative number. And now you're going to ask, why is that the case? Okay, the reason is, Excel takes things very literally. Okay, and when I say that, we're looking at payments. Okay, our payments of $3,000. If you're paying somebody money that's leaving your pocket. So it assumes that that number is negative. Okay, so anytime you're making a payment, it's an outflow of cash. Okay, so that number in this cell should be a negative number. So if I change that to say negative 3,000, because it's an outflow of cash, this present value changed from being a negative number to a positive number. Okay, so you'll see that it switched from, there's no longer a negative sign, and it switched from red to green, or to black. Okay, you can also override that if you want to show it as green. Okay, but keep that in mind when you're doing these calculations. If you're getting a negative number, just think literally to what that is. Okay, so that's the first one, that's finding present value. Now I wanted to give you kind of an overview of each one of those features, including adding in each of these terms. It's things that I expect you to do, okay, if you're completing any types of assignments for me. Okay, at the end of the day, my goal for that is so that it looks professional, so that when you go into the workplace, you're not just throwing a bunch of text in here, numbers, and not organizing it properly or explaining yourself. Okay, I do expect you to do that, and for assignments, there is marks allocated to how professional your work looks. Okay, so that's the first one, that's future value. For the remaining ones, okay, I have written in each term here. Alternatively, if they're the same, you could have just highlighted these, pressed copy and paste to copy and paste them back down here. Okay, it's totally up to you. Our next one is to find future value. Okay, and it's going to be very similar to how we've done present value, with future value is just a slightly different formula. So find the future value of quarterly payments of $50 made at the end of each quarter for 10 years. And interest is 8% per annum compounded quarterly. Okay, so we've got all of our terms here. Let's just start inputting our values from the question. Our payment is $50. Remember, it's an outflow of cash. So we need to put this as a negative number, negative 50. Okay. You'll see that I have this selected as accounting, so it automatically comes up as a negative $50. Our nominal interest rate, J, okay, is 8%. Now we can select percent style here, or click the drop-down menu and click percentage. And I can just write 8 for 8%. Our number of compounding periods per year, okay, is quarterly, which means 4 per year. Our periodic rate of interest, remember, okay, again, I will convert this to a percent in my formula, so I will click the drop-down menu, go to percentage. It's equal to our nominal rate of interest divided by our number of compounding periods per year. Okay, so our periodic rate of interest is 2%. In our question, it was given that our investment was 10 years, so our length of investment is 10. Our number of payment periods is equal to our length of investment, 10 years, multiplied by our number of compounding periods per year. So once you input all of those formulas, you'll start getting used to them as you do more problems like this. Then we hit our future value formula, and it's the same. Remember, when we did present value, we did equals PV. Well, the same thing applies here, except we use FV, okay, for future value. And you'll see the first value here, FV. We're not going to talk about FV schedule today. We're just going to talk about FV. It returns the future value of an investment based on periodic constant payments and a constant interest rate. That's important, right? Remember, anytime the payments changed or the interest rate changed when we talked about compound interest, it was a different calculation we had to do. It basically broke our calculation up each time. So we do our left bracket. And once again, we've got our items here. Our rate, which is our interest rate. Remember, that's our periodic rate of interest. Select periodic rate of interest. NPER is our total number of payment periods. Select 40. PMT is our payment. We'll select the $50 there. Then once again, we have two items that are in square brackets, meaning optional. PV, which is present value if you knew that. We don't have that provided in our question. Type in 0. And our last item is, are they at the end of the period or the beginning of the period? Remember, this is ordinary simple annuities. The standard is end of the period. Okay, so we're not going to talk about annuities D right now. So I'll type in 0 and finish with our right bracket and press enter. And you'll see it comes out as a positive number here once again because our payment, our outflow of cash, was inputted as a negative number. Okay, so that's using the future value formula. So scrolling down, okay, we have finding payment knowing the future value. Okay, so we're going to do it both ways. Finding our payment knowing the future value, and then finding our payment knowing the present value. So starting with the future value. What deposit made at the end of each quarter will accumulate to $10,000 in 4 years at 4% per annum interest compounded quarterly? Okay, so we're given in the question, it's accumulating to $10,000. That's telling you, okay, that our future value is $10,000. Okay, so I'll type in 10,000. Again, I have this specified as accounting. Our nominal interest rate given in the question is 4%. So I can click my drop-down menu, go to percentage, type in 4%. Our number of compounding periods per year, it's compounded quarterly, which means 4 periods per year. So our periodic rate of interest, once again, I could put this as a percentage. You don't have to. Again, you can keep them as decimals if you choose to. So our periodic rate of interest, I, is equal to our nominal rate of interest divided by our number of compounding periods per year. And we arrive at 1%. So our length of investment in years, okay, it's given in the question that it's happening over 4 years. So our number of payment periods, how many times we have to make our deposit, is equal to our length of our investment multiplied by our number of compounding periods per year. And we arrive at 16, 4 years times 4 compounding periods per year. So now we arrive at our formula, payment. And it's just like it looks, PMT. So we do equals PMT. And you see, for PMT, calculates the payment for a loan based on, again, constant payments and a constant interest rate. Very, very important when you're considering using these formulas. Remember, anytime our interest rate or our payments change, okay, you have to basically break that up into multiple calculations. Start with our left bracket, okay, and you'll see here that we have our rate, okay, which again is our periodic rate of interest. NPER, which is our total number of payment periods, 16. In this case, we don't know the present value, right? It's saying it's required. We can just type in 0 because we don't know what it is. We get to our future value, the optional piece, we do know what that is. Okay, it's $10,000, so we can select 10,000 here. And then once again, it's going to ask you if payments are at the end or the beginning, okay? Unless it's an annuity due, it's the end of the period. So we'll type in 0, end bracket, and we're done. Notice that the answer is negative, okay? Once again, remember, it thinks of a payment as an outflow of cash, okay? So it's going to show up as a negative number unless you were to override, let's say, future value to be negative $10,000, okay? Something to be negative in that formula to allow that to adjust. But it's okay for it to show up as negative. Okay, again, because Excel's taking things literally. Okay, it's just using algorithms to calculate things. Okay, now to find the payment using the present value. So you're going to see it's the same formula. Just the difference is whether or not we're inputting the future value or the present value within those two variables. Remember, one of the two is shown as optional. So in this question, what payment should be made semi-annually at the end of each period? Okay, so you can see in this question, I've listed it as at the end of each period, and we'll talk about that when we get to the formula. To pay off a loan of $8,000 in 10 years if interest is 10% per annum compounded semi-annually. So like I said, we're looking for a payment, okay? It's a loan of $8,000, meaning that's the present value. That's the amount of money that if you go to the bank, you're going to get $8,000 today. So that's your present value, not your future value. The other item it notes is that at the end of each period, again, that's telling you, okay, that it's a simple annuity, okay, not an annuity due. All right. So let's just start inputting our values. Move down a little bit here. So our present value is $8,000. Okay. So again, we can just write 8,000. You can see I have it listed as accounting here. Okay, so it shows as dollars and cents. For the nominal interest rate here, okay, I have it as general up here. I can click percentage, or remember, go to the drop-down menu and click percentage as well. Our nominal interest rate is 10% here, so you type in 10. You'll know that you have the correct cell type as percentage when the percentage sign automatically comes up. Okay, so we type in 10 here. Our number of compounding periods per year, it says it's compounded semi-annually, meaning 2. Our periodic interest rate I can therefore be calculated. It's equal to our nominal interest rate, 10%, divided by our number of compounding periods per year. So we arrive, see, at 0.05, but if we go up here, we can click percent, and it'll convert to 5%. Our length of investment, okay, our loan is paid off over 10 years, meaning that our length is 10 years. And our number of payment periods, therefore, can be calculated equal to, we have 10 years times 2 compounding periods per year, okay? So a total of 20 payments to pay off this $8,000 loan. So for our payment, remember, it's the same as the acronym in the formula, PMT. So our first item is our rate. Remember, that's our periodic rate of interest. Next, we have our number of periods, which is our total number of payment periods, 20. Now it's asking, do we know the present value? In the previous example, remember, we didn't. Here, we do. So you select $8,000. Then our next item, it says future value. Again, remember, with square brackets, meaning it's optional. We don't know this, so we can type 0. And then remember, this question stated end of the period for payments. So it follows end of the period here. Type in 0 for that, end bracket, and enter. Again, you see our payments are a negative value, okay? That's because it's an outflow of cash, all right? Just to reiterate that point. Okay. Our next items are going to look at finding n. Again, n being the total number of payment periods. In this first example, we'll look at just finding n. In the second example, we'll also see how to take that value of n and convert it back to a number of years to pay it off. So, first example, how many quarterly payments of $600 are required to repay a loan of $5,400 at 6% per annum interest compounded quarterly? So, once again, okay, we have quarterly payments, and anytime you see that you're repaying a loan, that loan value is always your present value. Okay, I want you just to kind of start being able to pick apart the little pieces in the wording of the question, because that really tells you what type of question it is and what you're trying to solve. So in this case, we know, okay, oh, sorry, going up. I didn't realize it scrolled that far down. Our present value is $5,400. Again, I have that as accounting. Our payment, I also have it as accounting, okay, because we know what our payment is this time. Our payment is $600, okay? So remember, payment is an outflow, so you can type negative 600 because it's leaving. Our nominal interest rate given in the question is 6%, okay? So again, I'll go up here and I'll select percentage and type in 6 as the percent. Our number of compounding periods per year, it's compounded quarterly. Okay, so that means 4. Our periodic rate of interest then is equal to our nominal rate of interest divided by our number of compounding periods per year. Okay, so I could convert this to show as a percentage by selecting this button. I'm going to leave it like this just to show you that regardless of which way you select it, the answer will still come out. Okay, so same with, so right now I have one of each. One is percentage and one is not. So now we have the number of payment periods. Remember in our formulas, it was always showing up as NPER. And that's because that's actually the formula to calculate this. So equals NPER. And you see as you start typing it, it narrows it down very quickly to the correct formula. It returns the number of periods for an investment based on periodic constant payments and a constant interest rate once again. Okay, so again, I stress that to you that your payment and your interest rate can't change, or you have to then restart that formula at that period in time where one or both of those changed. So we have our number of periods, NPER, and now here's what it's asking us for. Our interest rate, remember it's always the periodic rate of interest in these questions. Next we have PMT, our payment, so we can select that here. We have our present value, $5,400, we select that. Next, just like before, it has two optional items. The first one, future value. We don't know that, so we type in 0. And lastly, our type, again, we're not dealing with annuities due, so end of the period, we'll type in 0. Okay? So when we press enter, you'll notice I have a positive number here. Okay, 9.74 payment periods. Again, with a loan, remember that would mean that you round up to 10 payment periods, right? Because after your 9th payment, you still have a portion of your loan left over. Okay, just it won't be the full payment value of $600. It might be something like, $450 or something like that. Okay, so it'll be a portion of it. Okay, now that number may come out negative for you, and that's if, remember, back to our principle of payments being an outflow of cash. If we put that as a positive number, okay, you see our number changes here, right? It's the number of payment periods changes to be a negative value, and we don't want that. So you have to make sure that you have here the right negative number. Okay. Now we're finding n with future value. So how long will it take for $200 deposited at the end of each quarter to amount to $5,726.70 if interest is 6% per annum compounded quarterly? Okay. So in the question, it's saying that it's asking how long it would take for these deposits to amount to a certain value. That means the future value sometime later on. So we know that that's our future value, $5,726.70. Next, we have our payments. Okay, we're depositing $200 at the end of each quarter. Again, an outflow of cash. We write it as negative 200. Our nominal interest rate is 6%. Okay, so I'll select percent style up here and type in 6. Our number of compounding periods per year, it's again compounded quarterly, which means I'll select 4 here. So our periodic rate of interest is equal to our nominal rate of interest divided by our number of compounding periods per year. Again, comes out to a decimal here. If I go up here to select percent style, it's rounding up, but that's just for show, okay? If you want to actually show the decimal places, which I do recommend in these cases, because that is a very, very rounded number. Up here, you have the option to increase the number of decimals or decrease the number of decimals. So we want to increase, and I'll show 2 here. Okay, so you see it come up as 1.50, and that's heavily rounded. So you want to make sure that in the case that it is going to be a decimal, that you're showing at least 2 decimal places here. So our number of payment periods can now be calculated the same formula, equals NPER. It asks for our periodic rate of interest, so we select this cell. Our payment, which we select here, of $200. Our present value, we don't know, right? We know the future value, so we type in 0. Future value, we do know, so we can select that cell. Again, it's optional because you don't input both. You either usually input one or the other. Next, our type. Okay, it's not an annuity due, so we type in 0 for end of the period and press enter. So our number of payment periods here is 24. Now, that's number of payment periods. That depends on, scrolling back up, what or how often it's compounded. This is compounded quarterly. So if we wanted to find the number of years, okay, we could say it's equal to our number of payment periods divided by how many times per year we pay, okay, which is our number of compounding periods per year. And if we do that, it comes out with 6 years, okay? So you can see in my question, I picked a very specific amount of money at the end because I wanted to get to what would be a perfect decimal as opposed to our example up here where it was 9.74, okay? So that's a way that you can go further, to not just find the number of payment periods. So there may be questions where I ask you, how long will it take? And maybe I want it in years, or maybe I want it in months, okay? So it'll be up to you to determine whether I'm looking for n or if I'm looking for the number of years. Okay, our last piece here is we're looking for finding our periodic rate of interest. And I'm also going to show you how to convert that backwards back to a nominal rate of interest, okay? Both with the present value and the future value, just like we've done in the past. So the first example, a loan of $6,000 is paid off over 5 years by monthly payments of $120.23. What is the nominal rate of interest on the loan? So it's asking for the nominal rate of interest, okay? But anytime you're solving for these, remember, we don't use the nominal rate of interest in any of our formulas. We use the periodic rate of interest. So you're always solving for the periodic rate of interest, and then you have to use that, okay, and your number of compounding periods to convert back to a nominal rate of interest, okay? So let's start by looking at this question. It's saying a loan of $6,000. Remember, loan means present value, okay? So our loan is $6,000, okay? That's cash coming into you. Our payments are $120.23. Again, our payment is negative because it's an outflow of cash. Our number of compounding periods, okay, it's monthly payments, okay, meaning our number of compounding periods per year is 12. Our length of our investment, we're paying it off over 5 years in time. So we can calculate our number of payment periods, okay? Remember, it's equal to our number of compounding periods per year times the length of our investment, which is 5 years. So we're making 60 payments of $120.23 to pay off this loan. So now to find the periodic rate of interest, remember in our formulas, it always showed this value of rate, and that was our periodic rate of interest. So that's the formula to use, equals rate, okay? And you see it returns the interest rate per period, so periodic rate of interest of a loan or an investment, okay? So for example, it says use 6% divided by 4 for quarterly payments. Remember, because your nominal interest rate divided by 4 is quarterly payments, but your nominal rate of interest is 6%. Okay, they call that APR. So in this formula, let's look at what it wants. Okay, it wants our number of periods, okay, which remember is our total number of payment periods. Our payment, $120.23. The present value, if we know it, which we do, $6,000. Our future value, okay, again, all three of these next ones are in square brackets. Future value, we don't know, so we type in 0. Type, once again, it's not an annuity due, so it's end of the period, 0. And lastly, you can put in a guess, okay, because it's going to try and find the answer that matches this, okay, that works so that your payment of $120.23, 60 of those will pay off your loan, okay? So if you don't have a guess, which in our situation, we're not going to have guesses, we're just going to type in 0, end bracket, and press enter. So now it comes out with a periodic rate of interest of 0.625%. But remember, okay, so you are going to see a little bit of my drawing here. Okay. Our periodic rate of interest is equal to our nominal rate of interest divided by our number of compounding periods per year. So remember, okay, back to your first math course when you're solving an algebraic equation. As long as you do the same thing to both sides of your equation, you're fine. So I can multiply both sides by m. Okay, the number of compounding periods per year. On the right-hand side, the m's cancel. And we're left with just our nominal rate of interest, and that's equal to our periodic rate of interest times our number of compounding periods per year. Using that, we can then simply, going back to our formula here, our nominal rate of interest, therefore, is our periodic rate of interest times our number of compounding periods per year, which is 12. Okay, so that comes out to a nominal interest rate of 7.5%. Okay, so 7.501 is what they show, but to round it off, 7.5%. Okay, so that's another way of working backwards to find one item like an interest rate. Okay, our last question. This time we're going to have future value. Compute the nominal rate of interest compounded monthly at which $100 deposited at the end of each month for 10 years will amount to $15,000. Again, nominal rate of interest, okay? So when you get your solution, you're not done, okay? You have to take that extra step to find the nominal rate of interest. And this is an amount, so it says $100 deposited at the end of each month for 10 years will amount to $15,000. That's saying the future value of your money in 10 years is $15,000. So that's your future value here, okay? Your payment is an outflow of $100 every month, so minus $100. Your number of compounding periods per year, again, it's compounded monthly, so you have 12 periods a year. That's also how often you're making payments. Again, for an ordinary simple annuity, those two are the same. The length of your investment is 10 years. Okay, so our number of payment periods per year is 12 payments times 10 years. So you're making 120 payments of $100. Now we can calculate your periodic rate of interest. Remember, it's equal to rate. First is your number of periods, 120. Your payment, $100. Your present value, we don't know, so we type in 0. But we do know the future value, the optional piece. So we go to future value, we type it in. The type, it's the end of the period once again, because it's not an annuity due. And once again, we don't have a guess. Okay? You can put a guess in. If it's more complicated questions, sometimes the answer comes a little quicker. So it comes out with a periodic rate of interest of 0.363%. But remember, that's not the nominal rate. We have 12 compounding periods per year. Remember back, our nominal rate of interest is our periodic rate of interest multiplied by our number of compounding periods per year. So that's equal to our periodic rate of interest times our number of compounding periods per year. And we arrive at 4.35%. Okay? So that is it for this lesson. I wanted to show you kind of how to do, each one of these formulas. Okay? I hope you found this helpful. I hope you found this a little bit of a refresher helpful as well. If you have any questions, please send me an email or a message on Teams. Thanks, everybody.